Good morning, students. Today we will start about electrophoresis. We'll study about the electrophoresis process and how the electrophoresis will be happening and what are the importances of it and what are the different types of electrophoresis we have. All those things we will study now. So first, basically, we should know what is electrophoresis. So electrophoresis, you call it as migration or the movement or the mobility. So electrophoresis is the separation of charged particles under the influence of electric field. So under the influence of electric field, we will be doing the sharing of moving the charged particles in order to separate them to the greater extent. So we wanted to separate them. So automatically we will be migrating it in the under the electric field. Usually the purpose of your electrophoresis is to mobilize or is to separate the charged particles. That is the utmost importance of your electrophoresis. So the basic principle behind the electrophoresis is the spherical molecule or any shaped molecule, if it possesses the net charge Q, which is placed in the electric field, the force F will be acted upon this particle will depend upon the net charge density of the molecule and the strength of the field in which it is placed. So F is equal to del E divided by Q, where del E divided by D will be the field strength which is applied, whereas the size and the shape of the molecule and the viscosity of the media, everything will be determined with migration. And D between the distance, D is the distance between the electrodes. So based on this only, the mobility of the charged particle is taking place. So now we have capillary electrophoresis. So we'll start with the capillary electrophoresis. So capillary electrophoresis has grown to become a collection of a range of separation technique, which involves a high voltage across the buffer-filled capillaries to achieve separation. The separation based on size and charge differences between solutes. The technique which uses the above principle is termed as capillary zone electrophoresis or free solution capillary electrophoresis. The separation of neutral compound using surfactant micelles, this technique is called micellar electrokinetic capillary chromatography. Separation by sieving of solutes through gel network, this technique is termed capillary gel electrophoresis. Separation of zwitterionic solutes within a pH gradient. This technique exploits the isoelectric focusing technique and thus is called the capillary isoelectric focusing. Capillary electrochromatography is also termed because the separation involves both electrophoretic and chromatographic procedure. The technique involves applying voltage across capillary filled with silica gel stationary phases. Operation of a capillary electrophoresis. So operation of CE system involves application of high voltage across a narrow bore capillary. The capillary is filled with an electrolyte solution. The electrolyte solution, which will be used as the separating medium. So the instrumentation, when we check, CE instrumentation consists of an electrolyte filled capillary, which passes through the optical center of a detector. So a sample injector is there, a high voltage power supply is there, and an auto sampler is there. The entire instrument is computer controlled. So we can see the image in which two buffer vials are there, and those buffer vials will be connected by means of capillary. And in between the buffer vials, we have the detector. So the detector is placed in between the capillary, and through the detector, it is attached to the computer, and both the buffer vials are connected with the high voltage supply because the capillary electrophoresis requires very high voltage in order to separate the molecules. So the capillary tubes, how the capillary tube should look like and what are all the things you should consider when you select the capillary, all those things we'll see now. The capillaries used here are specially designed to give an enhanced mechanical strength. Fused silica capillaries, which are extremely fragile, or given an external coating of a polyimide. This coating is responsible for increased mechanical strength. Since this coating can impinge the signals passing through the detector, there is a small portion of the capillary from which this coating is removed. This point in the capillary serves as a window for the detector and is aligned with the optical center of the detector. The length of the capillaries used varies from 25 to 100 centimeter. The inner diameter of the capillaries used varies from 50 to 75 microns. The capillary volumes are of order of a few microliter. The inner wall is also often chemically modified by coating of different chemical substances. These substances are covalently linked to the inner wall. The inner coating either serve to change the ionic property of the wall or to reduce the sample adsorption. Temperature control. Optimum temperature needs strictly to be controlled. To achieve this, the inner capillary cartridge is placed inside the capillary electrophoretic system, which is regulated by the liquid coolant system so that it regulates the temperature. The sample introduction. The sample can be introduced into the capillary through different ways. One way is to dip the capillary into the sample vial and then apply the force so that the sample will just move into the capillary. The alternate method is to dip the capillary into the sample vial along with the electrode. Then you give the appropriate voltage. Automatically through the capillary, the sample will be moving inside. Of course, this method works which ionizes the sample. So the second alternative method will work if the sample is charged. The later method of sample introduction is called the electrokinetic sampling method since it involves the voltage. The common thing is to introduce the sample at the capillary end that is farthest from the detector. So which is very far away from the detector. At that end of the capillary will be loaded with the sample. This allows maximum passage to the substances for separation before they reach the detector. The volumes of the sample vary from 10 to 100 nanoliters. The detectors. Most capillary electrophoresis instruments use the UV absorbance detector. Several other detector modes such as fluorescence, conductivity, and even indirect detection can be used. For highly involved structural studies, capillary electrophoresis system with an interface with mass spec are also available. So power packs, the power packs used must be able to supply high voltage in the range of 10 to 30 kilovolts. The electrolyte ionic strength is necessary so that these voltage generate current between 20 to 100 milliampere. This is important because currents higher than these gives rise to band broadening and loss of resolution. Several mode of power packs have the ability to supply either constant voltage or constant current. Electroendoosmotic flow. Electroendoosmotic osmosis is probably the most important factor in fastest analysis time and better resolution affected by capillary electrophoresis. The silica wall contains selenols. The selenols ionize when they come in contact with high pH electrolyte solution. This ionization produces a wall which is negatively charged. So as seen in the diagram, the silica which has OH group, which will be ionized so that we produce the negative charge. A layer of metal ions is then established at the wall to preserve electroneutrality. This flow is called as electroosmotic flow. This movement of ions and their associated water molecule results in the flow of solution towards the detector. This flow can be very powerful and is capable of pumping solute ions along the capillary and generally towards the detector. This leads to faster resolution in capillary electrophoresis and lesser peak broadening. At low pH, the selenols are unionized and therefore the flow rate is much reduced and can become zero at very low pH values. Thank you, students.